Hi students, my name is Suram and I welcome you all to the next lecture of ICSE Standard 9th, Chapter 1st, Measurements and Experimentation, Unit 4. So in this we are going to discuss about the Micrometre Screw Gauge. So here is the picture and its different parts of Micrometre Screw Gauge. So we will discuss. It is an instrument used to measure very thin objects and its accuracy is up to 0.01 centimeter, and it is commonly called the Micrometre Screw Gauge. So we will discuss about the different parts one by one. Its construction. It's having the U frame, right, which is a fixed steel frame having a fixed jaw A, that is called the stud, and on the other end a movable jaw B. And next part is nut and screw threaded outside and can move inside and outside in nut, which is threaded internally. Then we have thimble or circular cylinder. The screw rotates inside the nut attached with the circular hollow cylinder, that is called the thimble. Sleeve cylinder, it is attached to the hollow cylinder and through which the spindle of the screw pass. Baseline, there is a reference line parallel to the axis of nut. It is graduated in mm on the sleeve cylinder. This is called the main scale or the sleeve scale. Circular scale or the thimble scale, the scale at the taper end on the sleeve is called the circular scale or the thimble scale or head scale. It can have up to 50 or 100 divisions. Then we have ratchet. It is attached to the screw by spring and produced a rattling sound, and when the screw and B of combines with the stud A, that indicates and B is not further pushed towards A. These are all about its parts. Then there are some terms related to this. Pitch of the screw. Pitch is, it is the distance between the two consecutive threads of the screw. This is the very first definition. Secondly, we can define it as distance traveled by the tip of the screw, that is end of B, when head of the screw is given one complete rotation. Mathematically, we can say pitch is equal to distance moved by the thimble on the main scale over number of rotation of the thimble. Then we have the least count of the screw gauge. We have defined the least count of the vernier calipers also. So here is the least count of screw gauge. It is the smallest distance traveled by its tip when the screw is turned through one division marked on it. So mathematically, least count is pitch over number of circular scale divisions. So how to use the Micrometre Screw Gauge? That is important to know now, how to use it. So very first we need to calculate the least count and the zero error, if any, right? Zero error, as we have discussed the errors in case of vernier calipers. So our screw gauge can also have the zero error, right? So that we will see how to check it. Fix the given wire in between the stud A and the screw B by moving the ratchet till it becomes free. And we have to note on the reading, main scale reading from the left hand side of the circular scale, and circular scale reading from the number of divisions that are coinciding with the baseline, number of division of the circular scale that is coinciding with the baseline or the reference line. Then we need to add the main scale reading and the circular scale reading to obtain the observed reading, and finally we need to subtract or add the zero error. Then observed diameter will be main scale reading plus circular scale reading into least count, and the true diameter will be observed reading plus minus 0 error, right? So same way it will have the two kinds of error again, positive error and negative error. So we will discuss about the errors. Determination of 0 error. How to check that this screw gauge is having any error? Then on bringing the two end, that is screw end B in contact with the stud A. If 0 the main scale does not coincide with the 0 of the circular scale, then micrometer screw gauge is said to be have an 0 error. So there are two types of errors, positive error and negative error. Positive error, if the 0 of the circular scale is below the reference line, then there is positive error and its correction will be negative. Correction will be minus coinciding division of circular scale into least count. Then corrected diameter will be observed diameter plus correction. Means if there is a positive error, then we need to add the positive error in the observed diameter. Negative error, if the 0 line of the circular scale is above the waistline, then there is negative error and its correction is positive. Then correction will be equal to, it's having some different formula to calculate. Correction is equal to plus n minus coinciding division of circular scale into least count. So that you need to remember this formula for finding the correction, plus n minus coinciding division of circular scale into least count, where n is the total number of circular scale division, right? So corrected diameter will be observed diameter plus minus correction, right?